Congruent triangles. They're back. I know that you just took your test on Friday and you were thinking that we were done with congruent triangles and all of our theorems for congruence, but you were wrong. We are going to continue to expand on congruent triangles for a little bit longer. What we're going to do now is move on to inferring congruent parts based on given information rather than the parts already being marked. Okay, so you're going to be given pieces of information that are not going to be on the triangle and that you have to know the definition of in order to understand what's congruent. So I want you to look at the problem in the middle of the screen. It says, which theorem proves the triangle's congruent? Given C bisects BE, C is the midpoint of AD. Alright, that's all we're given. And we've got our triangles over there. So we have to take those words and determine what they mean. So this first one is about the definition of bisect and midpoint. And you probably already know these. Alright, so it says that C bisects BE. That means that point C is in the middle of BE. If something bisects something, it means that it cuts it in half and the two parts are congruent. So we know now, because C bisects BE, that BC is congruent to CE. We also know that C is the midpoint of AD. Well, midpoint is the same idea of bisecting. If something is the midpoint, it is in the middle, so it creates two congruent parts. So if C is the midpoint of AD, that means that AC is congruent to CD. And looking at the picture, you know that there's one more thing that you know is congruent. We know our vertical angles are congruent. So now we have all of our information marked and we can determine that the two triangles are congruent by the side angle side theorem. Alright, so that's definition of bisect and midpoint. Another one that comes up is bisecting angles and the definition of two things being perpendicular. So look at the problem in the middle. Which theorem proves the triangle's congruent? We're given that line XZ bisects angle WXY, and we're given that XZ is perpendicular to WY. And we got our picture. Alright, so let's take what we've got. We know that XZ is bisecting this angle. Alright, so we got to locate that angle. That's WXY. So WXY. That means that this line is bisecting that. And when something is bisected, it's cut in half. So we know now that this angle is congruent to this one because of the definition of being a bisector. Alright, if something is bisected, it's cut in half. The other one says that XZ is perpendicular to WY. So that's our line XZ right here is perpendicular to line WY. That's our side. When something's perpendicular, it creates 90-degree angles. So I know right now that these two angles are 90 degrees because this is a perpendicular line. So when it says which theorem proves the triangle's congruent, I can see that I also have a shared side that's congruent right here. So my theorem that proves the triangle's congruent is angle, side, angle. Now let's look at one more. Definition of a perpendicular bisector. So we basically got the same thing flipped over, and we're given ON is a perpendicular bisector to LM. Alright, so here's ON, and here's LM. So we know it's going to bisect LM. Alright, so ON is a perpendicular bisector to LM, so that means we know that MO is congruent to OL, and because it's a perpendicular bisector, it is creating 90-degree angles, so we know that as well. What else do we know just by looking at this? We've got shared sides. So which theorem proves the triangles are congruent? That would be side, angle, side. So the big part of this is knowing these terms, what a perpendicular bisector is, what an angle bisector is, what a midpoint is. All right, so there's going to be some new terminology we're going to be throwing out while we go through these next week, and well, this coming up week. So go to the questions and make sure that you know these terms as you go into the questions, because you're going to be asked to mark these pieces that are congruent.